Okay, so for the warm-up, we're just going to revisit a lot of what we've done already, you guys. Two-way frequency tables, we've talked about, we started doing that with conditional probability. You did it last year in Math 1. So quick warm-up on that for a couple problems, then we're just going to make sure we're good to go on conditional probability, comparing, writing those sentences, etc., and then some simple probability wrap up at the end. So hopefully, as I go through all of this, none of this is new to you. If it's new to you, then you need to see me outside of class for help, okay? So if you look, this two-way frequency table is already filled in for us. So it says find the following probabilities based on the two-way frequency table to the right. Oh, sorry. We moved it. It's above. All right, so the probability of BP, which is a basic phone, this is just in general, so that's 15 out of our sample space, which is 50. So then you're looking at 3 over 10, or 30%. Okay, I'm just going to stick with simplified fractions here. The probability of being over 35, okay, that's the O, is 13 out of 50, and obviously you cannot reduce that, so that's your answer. The probability of a smartphone is 35 out of 50, which reduces to 7 over 10, or 70%. Oops, that was a bad circle, but you get it. All right, now a quick review of our conditionals. So the probability of being under 25 given that you have a basic phone. Well, remember you guys, this is your sample space. So you're looking out of the 15 people who have a basic phone, how many are under 25? And that's 3. So 1/5 is your probability there. And then last but not least, the probability of a smartphone if you're over 35. So the number of people over 35 is 13. Out of those 13, how many have a smartphone? And that is 6. Okay. So remember, when you're dealing with conditional probability, what you're doing is you're really slimming down that sample space and not looking at the data in general as a whole, but just a piece of the data and then taking probability from that. So here, more work with a frequency table. We're going to build the frequency table. So it says Kieran likes number puzzles and is tackling the puzzle below. The puzzle is incomplete. When it's complete, one total at the end of a row will be the sum of the numbers of that row, and each total at the end of a column will be the sum of the numbers in that column. Find all the missing numbers to solve the puzzle. So if you look at this, you guys, that means each column has to add up and each row has to add up. So I'm looking at this first column right here. They have to add up to 25. Well, 10 and 10 is 20, which makes this 5. Okay, and then this column doesn't have enough information, and I'm just going to go columns and then rows. It doesn't really matter how you start. This column doesn't have enough information, too many empties, but this one, 30 and 34 gets you 64. So this needs to be 36 so that they add up to 100. Now, if we go by rows, 10 and 12 is 22, so this has to be 14. So 10 plus 14 plus 12 is 36. 5 and 8 is 13, so this has to be 17 because 5 plus 17 plus 8 is 30. And then the next row doesn't have enough information, but then the last one, 25 and 40 is 65, which means this has to be 35 in order to add up to 100. Now we can go back and look at these two columns. 14 and 17 is 31, so this is 9 to make that add up to 40, and I'm double checking my math. Yeah, we're good. Okay. 12 and 8 is 20, so that means this has to be 15 in order to make that 35. And then if you notice, 10 plus 9 is 19, plus 15 is 34. So that's how those all work. Okay, hopefully quick review for you. All right, number 2 says the two-way frequency table below shows the results of a survey of students when asked what their activity of choice was. Consider the following events that apply to a random student who participated in the survey. So we have a couple different pieces of information, 3 different grades, 10, 11, and 12, and 3 different activity choices, talent show, field trip, and dance. We're going to focus on the 10th graders and a field trip. Obviously, we could pull a bunch of information out, but let's not get crazy. We're just making sure that we understand the difference between conditionals and then how can we interpret them, and then are they independent. So first we're going to find the probability of 10 given they like field trips. Okay, so how many students like field trips? Well, we need to do some adding here. 4, 5, and 2 is 11. 8, 3, and 1 is 12. 2, 6, and 9 is 17. 4, 8, and 2 is 14. 5, 3, and 6 is also 14. And then 12. And the total, you guys, I noticed this on your quiz too. This is just one total. So 11 plus 12 plus 17 should be the exact same thing as 14 plus 14 plus 12. They both add up to 40. So it's not 80, it's just the one total, okay? So here, this says the probability of a 10th grader given they like field trips. So this is our sample space. The number of people who chose field trips was 12. Out of those 12, 8 of them are 10th graders. So our probability there is 2/3, or about 66.67%. Okay, now the probability, if we flip that, of a field trip given the 10th graders, okay, so the probability of a randomly selected student choosing a field trip given the 10th graders, let's see, so our 10th graders is now our sample space. And out of our 10th graders, there's 14 of them. Out of those 14, again, 8 prefer a field trip. Your numerator should not change. So 8 out of 14 is 4/7, or about 57.14%. Okay. All right, so it says interpret the results. Well, if you notice, the higher percentage is in the first probability we found. So both of these have 8 kids that are in 10th grade and prefer field trips. However, it is more likely that you will get a 10th grader who likes field trips if you choose from the group of students who like field trips. So it is more likely that a student, sorry, I don't know what's up with my computer, will choose, let's see if I can make this better, a field trip, nope, choose a, sorry, field trip I don't like the way that is. Sorry, you guys. I'm going to erase this and start over. I don't like the way the sentence is coming together. And, I mean, who writes like that? Sorry. Okay, let's try it again. Okay, so I'm actually going to type. There we go. It is more likely that given the group of students who like field trips, a 10th grader will be chosen. Okay, perfect. There we go. And hey, it's a little legible. Thank you, typing. All right, cool. So there's the conditional. Okay. Now, the other part of this question is, are they independent? Okay. Do their probabilities affect one another? So if you look, the probability of 10th grade and a field trip is the probability of 10th grade times the probability of a field trip. Sorry, you guys, I don't know why my computer looks like this, but hopefully that is good enough that you can read it. Okay, so how many students are in 10th grade and like a field trip? Well, we already can kind of tell that that's 8 out of the 40. Remember, we're looking at the whole population. The probability that a student's in 10th grade is 14 out of 40. And the probability that they like a field trip is 12 out of 40. Okay. So, when you calculate that, you end up with 20% on this side. And then, oops, when you calculate the other side, you end up with 10.5%. So, very clearly, those are not equal. So, these are dependent. Okay. So, if you're going to write something for that, again, let's type it. Okay. Oh, sorry, now my Alexa is talking to me to remind me that it's garbage day. All right, sorry if you can hear that. Okay, so they're dependent. So that means a randomly selected person being in 10th grade does affect the probability that they prefer field trips. Perfect. All right, let me center that for you. Okay, perfect. So there we go. Cool. Sorry that got a little messy in there because my computer's not keeping up with my writing. But quick review of comparing and then independence. Okay. Now, on the back, I suggest you pause the video and then do this one and see what you get. I clearly will walk through it. If you need to hear that, then listen to that. Otherwise, you can just do it and then check your answer by fast forwarding a little. So, it says a cafeteria manager recorded the choices of 100 students who each chose one food item and one beverage. The table shows the data. Consider the following events that apply to a randomly chosen student who selects one food item and one beverage. Okay, so we're looking at milk, burgers, and pizza. And I don't even think we need the pizza because we're just going to focus in on milk and burgers. So if we add these together, we get 58. If we add these together, we get 42. If we add that together, 34 and 26 is 60. 24 and 16 is 40 for a total of 100 students. All right, so if we compare, let's see. So we have the probability that the student selects milk out of this, given the students who select a burger. So our sample space is the people who chose a burger, which is 58. And out of those 58, 34 chose milk. And then if we flip-flop it, out of the milk, that's 60. 60 people chose milk. And out of those 60, 34 chose a burger. Again, matching numerators, that's how it should always be. So, at least when you're flipping. So we can tell by the numbers that we're going to be close. This is about 58.62%. And this is about 56.67%. So, I'm not even going to try writing. You can already tell my computer's decided to go on the fritz. It is more likely that, given the group of people who chose burgers, a person who also shows milk will be selected. Okay. All right. Let's try and fit this in nicely. There we go. Okay, now we still have to do the independents. So, if we're looking at are they independent, again, we have our independence rule. So, the probability of milk and a burger equals the probability of milk times the probability of a burger. So, milk and a burger is 34 out of 100. The probability of milk is 60 out of 100. And the probability of a burger is 58 out of 100. So we know this is going to be 34%. And then we have that is 34.8%. So we are within that 1% leeway. Okay. So we are going to say that these are independent, which means a student choosing milk does not have an effect on the probability they chose a burger. Okay. I should say a randomly chosen student, but you guys get the idea. Okay. All right. Okay, so hopefully at this point we've kind of beaten that enough and we understand it all. Let's run through a few simple probabilities here and make sure we're good to go on those. So you're choosing a card from a standard 52 card deck. What is the probability the card you choose is red and a queen? We want that to happen at the same time. There are 2 cards in the deck that are red queens out of the 52, so your probability is 1 out of 26. All right, the next one, you're choosing a card from a standard 52 card deck. What is the probability the card you choose is odd and less than 8? So odd and less than 8 is any of these, or any of these. So that's 1, 2, 3, 4. So 4 times 3, we're looking at 12 out of 52. Okay, so if we have 12 out of 52 and then we reduce that, we're looking at 3 out of 13. Okay, notice I'm not using any formulas. This is all simple probability, so you don't really need to worry about that. Here you flip a coin 3 times. What's the probability that there are 2 consecutive heads given the first flip is heads? Okay, cool. So I'm only going to look at 1/2 of the typical coin flip chart that we make. So heads, 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 tails, heads, tails, heads, and heads, tails, tails. I don't care about the ones that start with tails because it says given the first flip is heads. So I only care about those 4. Out of those 4, what is the probability there are 2 consecutive heads? Okay, it doesn't say exactly 2. So that counts and that counts. So it's 2 out of 4. Your answer is 1/2. All right, number 7, you are rolling a pair of 6-sided dice. What is the probability that the dice are the same or the sum is less than 5? All right, so the dice being the same, I'm going to highlight here, is all of my doubles. So I know there are 6 of those at least. And it is doubles, or the sum is less than 5. Let's try this. Why are you not working with me? Okay. So the sum being less than 5. So that's this one, this one, this one. I just got to go through and highlight them. Less than 5. So we're not counting 5. I think we've reached the point. Okay, cool. So green or yellow, it's or. So if it's green, count it. If it's yellow, count it. Just don't double count it, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of 36, which reduces to 5 out of 18. Okay. All right, you are choosing a card from a standard 52 card deck. What is the probability that a face card is also a spade? Okay, so what is the probability that a face card, there are 12 face cards. Also, we're dealing with conditional probability. So out of my 12 face cards, what's the probability I get a spade? Well, these are my face cards. These are my spades. So it's 3 out of 12, which is 1/4. You're rolling a pair of 6-sided dice. What's the probability that the sum is even and the product is odd? All right, so I am looking for an even sum and an odd product. I'm going to get rid of everything that I did before. Okay. Now, if we want the and, we want the overlap. So, I already forgot. Here we go. I'm not very good lately with the memory. Okay, sum is even, product is odd. Okay, so the sum being even is all of these. And I like to do one at a time just because otherwise I think too fast. Some of you guys might be able to do this way faster than me, which awesome for you. I don't think that way. So these are all of my even sums. And clearly there's a pattern, so that makes it a little easier. And then we want the product to be odd. So this has an odd product. This has an odd product. This has an odd product. These do not. This does, this does, this does. Those don't. These, and these. So we're looking for the overlap, which is 9 of those. So our answer would be 9 out of 36, which is 1/4. Okay. So hopefully this gives you a good idea of where you're at. This wasn't really anything new today. This was like complete review. So please, if there's anything that you're still stumbling across, use the remaining time wisely and ask questions that you have.